Hi everyone, welcome to part 1 of Signs of Trig Ratios. Here's today's FLT. Given conditions of trig ratios, I will be able to determine which quadrant the angle is in. So by the end of today's lesson, you'll be able to tell whether a trig function is positive or negative based on which quadrant the angle lies in. So before we get started with the main topic, let's review the 6 trig ratios. In your notebook, go ahead and write out the 6 trig ratios that we've been talking about. Feel free to refer to your past notes if needed, and then press play when you're ready. So we have a total of 6 trig ratios. The first one is that sine of theta is the opposite side of our right triangle over the hypotenuse. We also have cosine of theta, and again, theta represents an angle. And this is the adjacent side, the side right next to us, over the hypotenuse. We also have tangent of theta, which is the opposite side over the adjacent side. So here are the original 3 trig ratios. And remember, we've been using the idea of SOHCAHTOA to help us remember these 3 trig ratios. We also have been talking about 3 more trig ratios, which are simply the reciprocals. So we have the cosecant of theta as the hypotenuse over the opposite side. So this is just the reciprocal of sine of theta. And then we have secant of theta, which is the hypotenuse over the adjacent. So this is the reciprocal of the cosine function. Lastly, we have cotangent of theta, which is the adjacent side over the opposite side. So we've been looking at the 6 trig ratios. Today we're going to take a break from looking at the opposite sides or the adjacent sides, and we're simply going to focus on the signs of the trig ratios. So will the trig ratios be positive or negative? So today we'll be looking at the coordinate plane split up into different quadrants. This is going to lead into the eventual idea of the unit circle, but we'll talk more about this when the time comes. So right here, I drew a circle going in counterclockwise motion, so going the opposite way of a normal clock. We start at 0 degrees, and if we go full circle, we're doing a full 360. What if we go halfway around this circle? Sorry, my highlighting skills are not the best right here. But if we go halfway around this circle, we go 180 degrees. What if we move a quarter around this circle? In this case, we are moving from 0 degrees to 90 degrees. And lastly, what if we move 3/4 of this entire circle? Then we're moving 270 degrees. So we split the circle into 4 quarters basically, and each of these quarters is called a quadrant. So in the top right corner, we have quadrant 1. So anything between 0 and 90 degrees is considered to be in quadrant 1. Anything between 90 and 180 degrees is quadrant 2. And anything in the 3rd quarter of the circle, so anything between 180 degrees and 270 degrees, is quadrant 3. And lastly, in the bottom right, we have quadrant 4. Between 270 and 360 degrees. So we have 4 different quadrants going from the top right, quadrants 1, 2, 3, and 4, ending in the bottom right. And again, we'll talk more about this when we get more into unit circles. But the whole idea here is basically you can move a certain amount of angles from 0 degrees. So this, we're moving theta degrees. And notice how we can create a right triangle. So this is the basic idea behind the unit circle, which again we'll be talking about in future lessons. So today we're simply going to focus on the signs of trig ratios depending on which quadrant they lie in. And so here is our circle from earlier. Notice that it's split into 4 quadrants, going from quadrant 1 to quadrant 4, and each quadrant is 90 degrees. Notice as a little subtitle here, I've written all students take calculus. But what exactly does this mean? It's actually a tool to help us remember signs of trig ratios. So in each quadrant, we're going to put the letters A, S, and then T, C. So all students take calculus is a way to remember this order, but what does each part actually stand for in terms of trig ratios? A stands for all, and S stands for sine. So T stands for tangent, and what do you think C stands for? Cosine. But still, what exactly does this tell us? So this actually tells us which specific trig functions are positive in each specific quadrant. So for example, let's focus on quadrant 1, so anything between 0 and 90 degrees. Notice how it says all. This means that all trig functions are positive when in this quadrant. So for example, let's say we have sine of 42 degrees, which is between 0 and 90 degrees. If you plug this into your calculator, you get 0.66913 and it keeps going. Basically, you get a positive answer. You'll get a positive answer if you try something like tangent of 35 degrees or cosine of 21 degrees. So whenever your angle is in this quadrant, so between 0 and 90 degrees, any trig function will end up with a positive answer. Let's look at quadrant 2, so anything between 90 and 180 degrees. In this case, only sine functions will result in a positive answer. So for example, sine of 102 degrees, let me plug this into the calculator. This results in 0.9781, keeps going, but anyway, it's a positive answer. But if it's not a sine function, the answer will be negative. So only sine functions would be positive when the angle is in this quadrant. So for example, cosine of 102 degrees results in negative 0.2079, and it keeps going. It's a negative answer. So in this quadrant, cosine would result in a negative answer. And definitely try plugging in some trig functions and angles on your own as well to see the differences. So for example, tangent of 133 degrees would also be a negative answer. So whenever your angle is in quadrant 2, so whenever your angle is between 90 and 180 degrees, only sine functions will be positive. Next, let's look at quadrant 3. So anything between 180 degrees and 270 degrees. So in this area, only tangent functions will result in positive answers. So for example, tangent of 190 degrees or tangent of 235 degrees. And lastly, in quadrant 4, so anything between 270 and 360 degrees, only cosine of those angles would result in a positive answer. So if your angle is between 270 and 360 degrees, only the cosine functions would result in a positive answer. So this thing, all students take calculus. So A, S, T, C help you determine whether the trig function is positive or negative in that specific quadrant. So this idea of ASTC, all students take calculus, helps you determine if trig ratios are positive or negative in each quadrant. And if you come up with a different phrase that helps you remember ASTC better, feel free to use that instead. But I like to use this idea of all students take calculus. So make sure to write this down in your notebook if you haven't already. Remember, each quadrant is split up by the 90-degree increments. And before we move on to any examples, I just wanted to quickly review these symbols because I know it can get confusing. On the left side, we have the less than symbol. Notice how it's sort of shaped like an L, so that's a good way to remember less than. And then on the right side, we have the greater than symbol. So we'll be seeing these a lot in these upcoming examples. So today, we're going to be determining the signs of different trig ratios. For our first example, we're going to determine the sign of 192 degrees. It sounds really weird because I'm saying sine like positive and negative, but also sine like the trig ratio. Anyway, we're going to determine whether sine of 192 degrees is going to be positive or negative without using our calculators. So we're just going to use this idea of ASTC, all students take calculus. So we're looking at the function sine of 192 degrees. So first off, let's figure out which quadrant this lies in. 192 degrees would be somewhere around here, definitely between 180 and 270 degrees. So it's in quadrant 3. So our angle for this trig function is in quadrant 3. And based on the idea all students take calculus, or ASTC, we know that when we're in quadrant 3, only tangent functions will result in a positive answer. So this T tells us that only tangent functions will be positive in that quadrant. In this case, we're looking at sine of 192 degrees. And so we know that this is going to be negative, so less than 0. So sine of 192 degrees is negative, and we know this because it lies in quadrant 3, where only tangent functions would be positive. Let's look at example 2. You don't have to write the entire problem down again, just like the cosine of 300 degrees part. So we're going to determine whether cosine of 300 degrees is positive or negative. So we have cosine of 300 degrees, and let's think about which quadrant this angle lies in. 300 degrees is somewhere between 270 and 360 degrees. So it's in the last quadrant. It's in quadrant 4. So our angle here, 300 degrees, is in quadrant 4. And we know that in quadrant 4, only cosine functions will be positive. And indeed, we have a cosine function, so we know that cosine of 300 degrees is greater than 0. so we know that cosine of 300 degrees will result in a positive answer. We were able to determine that cosine of 300 degrees is positive using the fact that the angle 300 degrees lies in quadrant 4. For example 3, we're going to determine the sine of tangent of 260 degrees. So first off, we ask ourselves, where does 260 degrees lie in terms of quadrants? So 260 degrees is somewhere in quadrant 3, probably around here. So this angle lies in quadrant 3. And we know that in quadrant 3, only tangent functions, so the t helps us know that only tangent functions are positive. And indeed, we are working with tangent of 260 degrees, so we know that this will result in a positive answer. Let's look at 2 more examples. And for these examples, remember you can pause at any time and rewind and rewatch if necessary. And you can also walk through the examples on your own and then press play when you're ready. So here we're looking at sine of 178 degrees. This lies in quadrant 2, really close to that 180. So Q2 stands for quadrant 2. And we know that in quadrant 2, only sine functions are positive. And we are working with a sine function right here. So we know that sine of 178 degrees will be positive. Here's the last example for today. We're going to determine whether cosine of 37 degrees is positive or negative. So let's see which quadrant 37 degrees lies in. So 37 is between 0 and 90, probably somewhere around here. So we are looking at quadrant 1. And in quadrant 1, notice the A, and A stands for all. So we know that all trig functions here will be positive. So cosine of 37 degrees will result in a positive answer. So for the examples we've looked at today, as well as the practice problems you'll be working on, focus on which quadrant the angle lies in, and then use the idea of ASTC, or All Students Take Calculus, to determine whether the function would be positive or negative when in that quadrant. So again, just as a quick review, use the idea All Students Take Calculus, so ASTC, to help you determine if trig ratios are positive or negative in certain quadrants. Great job today, and please remember to submit your notes on Canvas.